Good afternoon, ladies and gentlemen. It's Mr. Chen again for another lesson for my grade 9 math, MPM1D. This is an introduction to measurement unit. That's our last and final unit. This lesson is to supplement the Google Classroom that we've been having, and of course the CEMC courseware material that is available to you. I wanted to take some time just to go over some of the two-dimensional basic shapes and their formulas related to perimeter and area. The main idea for this lesson is on composites, on how to add and subtract these basic shapes that actually make it the composite shape. And then finally, a quick review of the Pythagorean Theorem, which will of course be incorporated in our composite problems. At any time, please feel free to pause the video, refer to your textbook notes, and of course, as always, you're more than welcome to email me to ask me any specific questions. So let's get started. I don't mean to insult you, but a lot of you already know the names of these shapes. And so we'll go through the shapes of these polygons. The first one, of course, is not a polygon, but it's the first basic shape. And it's clearly a circle. The next one we have is square. It doesn't have to be in this order. Third shape, of course, is a rectangle. We have some type of triangle. This is not drawn very well, but it's going to have to do. As you can see from my arrows, it's probably going to be a parallelogram. And our last of our two-dimensional basic shapes is a trapezoid. The trapezoid does not have to be a regular one. In terms of area and perimeter, really quickly, you should know the definitions. The perimeter is the length around the object, and the area is the space enclosed of that object. So let's take a look at some formulas that some of you already know. The circle, although the perimeter of the shape is actually called circumference, we use C for the circumference, and it is the equation of 2 pi r, where r from the center is the radius. 2 radius, or 2 radii, is called the diameter. So D for diameter. The area of a circle is equal to pi r squared. With a square, all 4 sides are equal. So the perimeter, you could have out of all 4 sides, but because they're all identical, it's actually easier to group them, called 4s. The area is equal to s squared. And again, some students actually know it as, for the rectangle, length times width, where that's the length and that's the width. But the perimeter is equal to 2 lengths plus 2 widths. Now, some of you actually know you can factor out a greatest common factor called the 2. And so some of you actually know the equation as 2 times L plus W. The triangle is pretty easy. We could have added up all 3 sides. And of course, if this was an equilateral triangle, we could just use 3s. But as it stands, probably in this scalene example, we simply add up all their sides. Side 1, side 2, and side 3. So I denote by using subscripts to actually show that. The area is actually equal to half base times height. So in this case, I'm going to make side 1 equal to the base, and this dotted line, the height. Half base times height. With the parallelogram, opposite sides are equal, and of course they are parallel in their lengths. And so for the perimeter, it's side 1 plus side 2 plus side 3 plus side 4, or you can group them, but most students actually know this as sum of all sides. For the area, it is going to be the base times its height. Finally, with the trapezoid, the perimeter is very similar to the parallelogram, sum of all sides. So add up all the four sides, the four lengths. And usually, top and bottom are parallel. In terms of the area, the equation is half times a plus b times h. What is a? A could be the top of the trapezoid, b could be the bottom of the trapezoid, and h, very similar to the triangle and to the parallelogram, it's the height. So those are the 6 basic shapes with their formulas. If we were to have the EQAO, you would have had a formula sheet that would help you with the 2-dimensional shapes and the 3-dimensional shapes. Hopefully this is the correct screen that's being shown. What you're seeing is questions 13, 14, 15, and 16 from the Math Power 9, our old grade 9 math textbook that I like to actually use to teach with our composite shapes. Now with composite shapes, we can actually add how come it's not adding? Or subtract our composites. A composite is actually made up of 2 or more of the basic shapes. And the question that I actually want to do with you is question 14. These 4 questions are supplementary. You can definitely use it if you want, or take a screenshot or pause the video and try these 4 extra questions and see if you can figure them out. I'm going to now go to the whiteboard, and hopefully that will show you the question. So hopefully you can see that I kind of reproduced that drawing as best I could on the whiteboard. And what we're going to do is find the area of the orange shape. Many of you actually understand we're probably going to be using the equation for area of a triangle. And it's half base times height. Now this orange shape, if I were to ask a student, it probably looks like a boomerang. It actually has a name. It's called a chevron. It actually looks like an arrowhead. And so the composite shape that actually makes this, believe it or not, we're going to be using the method of subtraction. A lot of you see a large triangle, and I'll hopefully draw it out first of all in maybe pink, but then I'll erase it. And that's the large triangle that we're going to use. So the total area is going to be area of the big triangle minus the area of the small triangle. So it's going to be 1/2. What's the base of the big triangle? 20.2. What's the height of the triangle? It's the 8.6 plus 6.2 for a total of 14.8 minus 1/2 of the base again, 20.2, times the height of the smaller triangle, which is 8.6. And if you're having difficulty understanding what that is, I will highlight that in light blue. This portion represents this area. So it becomes a calculator problem now. Using your calculator, hopefully we'll get an intermediate step. 149.48 minus 86.86, which equals 62.6 centimeters squared. We tend to worry about the units at the end because we're dealing with area, and we're just going to round to 1 decimal place. So now I'm going to take a look at the PDFs that I put in the Google Classroom. And then there's some answers for the measurement and vocabulary that we asked you to do. And then we have some perimeter and area basic shapes here to help you out. And again, the solution's already there. I think you're okay with that. A small little word problem. Then we get to the perimeter area of composite shapes. Again, there's posted answers to that. And if you need some more specific help, I can help you. But the one I want to actually help with you was this question here, question 2. And as you can see, I already did the answer for you. So let me just walk through it so that you can see it in clear detail. So it says, determine an expression for the perimeter and area of the following shape. And so I decided to solve for area first. And the area, total area, happens to be made up of maybe 2 rectangles. So I use the equation length times width. So the total area, area 1 plus area 2, I think some of you would have divided this into 2 rectangles this way. And again, some of you might have remembered doing these kinds of questions when we're looking at algebra. So this is an algebra problem. So 10x to the 5 times 2x cubed, that's this value and this value for the length and the width respectively, plus the length and the width for the area 2 rectangle, which as follows. Using our math skills, a lot of you realize 10 times 2 is 20, and then x5 to the times x cubed, we're multiplying that, but we use an exponent rule where we can actually add those exponents. And we do the same thing for the area 2. Of course, now we have 2 like terms, 20x to the 8 plus 35x to the 8. 20 plus 35 is 55. So 55x to the 8 is the final answer. For the perimeter, we actually had to figure out the unknown side. Now, technically, some of you can problem solve this and understand maybe we can actually extend that side, that 5x cubed, to this portion, and that 3x cubed, 3x to the 5th, to this side. But I'm going to do it that most students will do it and add up all of the 6 sides of this composite shape. So starting at the 10x to the 5, and I'll highlight this hopefully in light blue. Going in a clockwise fashion, we have 2x cubed plus 3x to the 5. We had to deduce that. How did we get that? 10 take away 7 is the remainder of 3. So that's where the 3x to the 5 is. Then we get 5x cubed plus 7x to the 5. And how do we get this 7x to the 3? That's 5x cubed plus 2x cubed for a total of 7x cubed. Add up all the like terms, 10x5 plus 3x to the 5 plus 7x to the 5. And again, when adding or collecting like terms, we simply add or subtract the coefficients. So 10 plus 3 plus 7 is 20, x to the 5. And the other like terms are the 2x cubed plus the 5x cubed plus the 7x cubed. And we get 14x cubed. So this is the final answer. So we're going to do our last composite shape. Again, the previous example was looking at the subtraction. No, it was looking at, yeah, a subtraction question, right? I think. I can't remember now. So now we're looking at our other perimeter and area composite figure worksheet with the Pythagorean Theorem. Really quickly as a review from grade 9, from grade 8, a lot of you know if we have a right angle triangle call that base A, B, and C, the Pythagorean theorem is C squared is equal to A squared plus B squared. So I wrote that at the top. So the question I wanted to actually do, I think question 1 is pretty straightforward. A lot of you can figure this out. Looks like a composite for the first one is a rectangle and a triangle. The second one is not so easy, and so we're going to do that one together. So here we go. It looks like some sort of portion of a circle and definitely a triangle. So the first thing that we probably have to do is maybe check our units. We have 100 millimeters at the bottom of this composite shape and 12 centimeters as this diagonal. I'm going to work in centimeters. So 100 millimeters is the same thing as 10 centimeters. And it seems like we have some missing dimensions to help us out or to figure out. So let's do that first. I think for the triangle, this dotted line, at first glance, it seems like we don't have enough information. But if you remember, it looks like a sector from a circle. So that dotted line, if this is the center of the circle, this is most likely going to be 10 centimeters. And the reason why, the rationale, is that's the radius. So that wasn't too hard to do. I'm going to use a different color to emphasize what I want to find next. Maybe let's look at the triangle and let's find this length. So I think a lot of you understand this portion is we need to find, and let's call that A, we need to find that base of that right angle triangle. So this is where we're going to use the Pythagorean theorem, except we're not going to be using it like we did in grade 7 or 8, where we try to find the hypotenuse all the time. The hypotenuse is actually given to us, it's 12 centimeters. So setting up, 12 squared is equal to A squared plus B squared. In this case, the B squared is the 10 centimeters squared. Evaluating the squaring, we get 144 is equal to A squared plus 100. So subtracting 100 to both sides, we get A squared is equal to 44. If you're one of my enriched students, many of you know this as an answer of A is equal to the square root of 44, or as in a mixed radical, it's 2 root 11. However, because we're dealing with measurement, most of you realize this is probably going to be approximately 6.63, and it keeps on going. I'm not going to truncate at 6.6. I'm going to keep that guard digit, that 3, just because we might need to use it later on. Now let's deal with that circle portion. This side, and I'm going to use hopefully this green, we need to find this length. So it's not really a circumference, because circumference is only really for circle, but we're using that idea to find that perimeter. And so what is that going to be? Let's call that Z. Well, doing some problem solving, believe it or not, this sector, which is a portion of the circle, happens to be a quarter of that circle. And so if we take a quarter of the circumference, that will give us the remainder, or our Z value. So let's write that out. So Z is equal to a quarter of the circumference. What's the circumference equation? Well, it's 2 pi r. What's the radius? In this case, it's 10. And doing some math, a lot of you understand as an exact answer, it's actually 5 pi centimeters. And I forgot our units in the other one. However, 5 pi centimeters isn't so useful. I'm going to take out my calculator really quickly. It's approximately 15.707 centimeters. So that sector from this portion all the way to this portion along that curve is that distance. So what is the perimeter of this question? It's not that hard. Starting with that diagonal of the 12 centimeters, we're going to take up the sum of all those sides. So that 12 centimeters plus that 10 centimeters plus that 15.707 centimeters plus that 6.63 centimeters. And those are the four sides. So taking up our calculator, adding those all up, 12 plus 10 plus 15.707 plus 6.63, and we get a total of 44.337 centimeters, rounded to one decimal place, 44.3 centimeters. In terms of the area, just like we problem solved to find that Z value, it's going to be a quarter of the area of the circle plus area of the triangle. Oops. Half base times height. Hopefully that's okay that a lot of you know what I'm doing. Quarter pi 10 squared plus a half. What's the base? We're going to use the A value as our base. So that's that 6.63. And what's the height? We're going to use that radius of that 10. Using our calculator to solve things. Again, we can get an exact answer. I think it's 25 pi plus something something. But you know what? Let's just use our calculator. We get 111.689 centimeters squared. And again, the one decimal place, 111.7 centimeters squared. Finally, just to talk about really quickly, question 2 and 3, I think you guys can figure those out using either addition and or subtraction. So if you have any questions, again, one more time, you're more than welcome to email me and ask me the specific questions that you're having or any questions from your textbook. With regards to your textbook, and I might have mentioned this, you can also look in the appendix, the back of the textbook, because it actually has some really good questions to support you. At any time, please feel free to collaborate with your classmates to make sure you understand this last unit of math. Thanks for watching. Take care. Have a nice day.